Hey guys, today I'm going to start with a basic topic of computer science, which is arrays. We'll see what arrays are. It is actually a container that stores items that we want to store. Okay, they are contiguous blocks of memories. We'll discuss in detail what these two actually mean. So for now, let's just erase this one. Let's see, why do we need arrays? Suppose you are told to store 100 values. Now a person who has no idea about arrays is going to do something like this: v1, v2, this is variable 1, variable 2, so on, and he will end up declaring 100 variables. This is possible, but this is not feasible. You can't do this in computer science. You will go mad like this, declaring 100 variables for each value. You can't do that. So instead what we do is we use a data structure called array. It's something like this. This piece of code actually tells the compiler that we want to store 100 values. This actually signifies the number of items that I'm going to store. Okay, and this one actually signifies the name of the array. It can be anything. It can be ABC, XYZ, anything of your choice. Anything. It can be anything actually. And this actually means that I'm going to store integer values in the array. Writing this line of code actually reserves a block of memory in the RAM of your computer. I'm written 100. Let's take an array of A 0, 1, 2, 3, 4, 5, 6, 7. So it's size 8. 8 values are there: 1, 2, 3, 4, 5, 6, 7, and 8. I can just store values, anything that I want, 30, 40, or anything that you want, you can store. This also contains some values. I'm not writing them. But there is a constraint. You can't store a real value or a decimal value in a, you can't store a value with decimal point in an integer array. Like this thing can't be stored in this array. For that you need a separate kind of array which is called as double array. It should be declared like this: double A 100. Now you can store any value you want in this array. Also keep in mind that the array name can be anything. It can be A, ABC, or whatever you want. It's totally up to you, whatever is your favorite name. So mainly there are two ways in which we declare arrays. We can declare it with the size, that is, I tell the compiler that I need an integer array which will store integer values. I'm going to name it as A, and I'm going to store 10 values in it. Inside the computer memory, you can think of as a memory block being created which has got your values. You can store them in this array. It's just like a container. Now what are indices? After all, if we are storing values, we need to retrieve them back, right? We don't want our values to get lost. 0, 1, 2, 3, 4. These are called the indices of the array. I can refer to each value like this, A10. This writing this line of code actually refers to the let's write A0. Actually, writing this line of code actually refers to the 0th value in the array. And what is the 0th value in the array? It's actually 10. Let's put 20 here, put 21 over here, 25 over here, and 26 over here. A4 actually refers to the fourth element, that is the element at fourth index, that is 26. And one more thing to note, that if I write something like this, a minus 1 or a20, in this array there is no index with no index minus 1, so there can't be any value over there. Also in this array there is no index called 20, so what will the compiler do? Compiler will return you a junk value, something like 0, 2, 3, 4, anything. It can be anything, a junk value, a completely junk value, a random value the compiler will give you. So keep in mind that the index that you are using is always within the limits of the array. There's one more method in C++ of declaring array. Also in Java the same method can be used. We write something like this and put square brackets over here, and we directly write the values that we want to store. This creates an array of size 4 with 4 integers, 10, 20, 30 and 40. So this is the second method which we use, and the first method being this one. We specify the size over here, type over here, and the name over here. And here we don't specify the size, but we directly put the elements, and if there are 4 elements, obviously the size is going to be 4, and the size is obvious from here, from the number of elements that you are writing within the curly braces. Now we'll go to the advantages. The most big advantage that you had was, in variable declaration, suppose you want to declare 100 variables, you have to declare v1, v2, v3 and v100, all you have to declare manually, right? That is not possible. That is not possible for any normal human being. So we use array. This single line of code actually declares 100 variables in just one line of code. You can imagine how powerful this line is. Also, you can access any element in O of one time, that is constant time. We'll discuss later about this, and this time complexity we'll discuss in depth afterwards in the later lectures. Now, if there are advantages, obviously some disadvantages will be there. Let's see what are the disadvantages of array. If you declare something like this, int a100, let's say 6, this means that only 6 elements can be stored at max. I can't store 7 elements or 8 elements. It's not possible, simply not possible to store more elements than what I have mentioned before. You have to mention the array size beforehand, you know. So that's a disadvantage. Maybe I declared something like this, like in 5, but later on I decided that I need more elements, maybe 6 elements or 7 elements. So now you can't change it because you have already declared your array as size 5. You can't increase the size of the array. That's a disadvantage. Also, there is a possibility of wasting memory. How that's occurring? Suppose I tell you that I'm going to give you some values, but you don't know how many values I'm going to give you. So you just, for safety, you reserve something like this, 100. But I give you just 5 values. Now the rest 95 places are being wasted. It's of no use. It's totally wasted. That's a disadvantage. You don't know exactly how many elements I'm going to give you. If I give you 5 elements, the 95 memory blocks are actually going to be wasted, and only 5 are going to be used. But if I give you maybe 100 elements, then all are going to be used. So let's just end this lecture over here. This is what we learned today, and the next lecture we will deal with linear search, which is a searching technique used widely with many data structures. We'll discuss those things. So let's end this lecture over here. Keep coding.